Hello students, welcome. In this video, we are looking at evaluating the limits of some functions through numerical approach and through a graphical approach. And we will be also analyzing or looking at the graphs of some of these functions and interpreting the meaning of left hand limit, right hand limit, asymptotes, and similar ideas. To clarify, we are not going to be evaluating the limit using laws of limits or some other analytic techniques. That will be for some other point in the coming chapters in this course, not at this time. However, I will be discussing, I will be giving you a kind of preview to some of those techniques, analytic techniques that we will use later, especially around the algebra and how to simplify and how to know when a quantity is positive or negative, how to deal with the square root signs and things like that. I will touch upon them where when we encounter a situation, but we are not explicitly going to use analytic techniques of evaluating the limits. Okay, so let me begin. The first problem you see here, the function is 3 sine x over sine pi x. And at a later point, as I was saying, with sufficient experience, you'll realize that as you take the limit of this function when x approaches 0, you will know, you can see it that the limit is going to be 3 over pi. Okay. Now, don't ask me how or no. I will just give you a teaser based on what you have seen in the lecture video just before this. Remember this result in limits, and I had mentioned that this is a significant and important result in limits, right? It's based on that. Okay. Based on that result, you can see, when I say see, mentally, you can see that the answer is going to be this. You can see the number 3 here, number pi here. You connect the dots, okay? Or even try proving it. Uh, it will be a fun exercise. What we are doing as per the section, the topic we have studied is numerical approach or graphical approach, okay? Numerical approach would be you will take a calculator and punch in this function at x equals 0 0.1, 0.01, negative 0.01, and so on. I have done that in the video, okay, that you should watch in case you have not watched before these problems. So instead of that, in this video, I'm going to show you the graphical approach, okay? And you can do this on a calculator graph. I have taken here the Desmos graphing tool. It's an You can do it online in a browser, or you can install an app on your device. And this is an app I installed on iPad. And the first function you can see on the top left. I don't know if you can zoom in. Yes, I can zoom in. That's the function 3 sine x over sine pi x. And we're looking at limit as x approaches 0, right? So what do you see here? Okay, close to 0, that's the limit you are getting, right? And you can see that, oh, yeah, I did not say something. Yeah, we are right. We are on good tracks. Okay, just a second. The units might have confused a little bit. That's because I had taken the scale to be 0.33 on the y-axis. Okay, I'm changing it now. Let's say I took it 0.22. Then you can see here. I can zoom in, and you can see as x is close to 0, the value is close to 1, okay, 0.8, 0.9, and even more than 0.9, 0.95. Actually, in fact, if you can see here, that would be 0.95. Okay, look at the scale carefully. I wish I could make it even bigger, the fonts. but looks like no. Okay. All right. And the rest of the graph doesn't matter. We are talking about limit as x approaches 0 here. Okay. And that is consistent with our understanding 3 over pi, right? Because how much is pi? 3.14 approximately. So that should be almost 0.95. Okay. And as it says here, the answer is E. Fine. Next. Um, did we copy? Oh, yeah, paper got copied. Here, this is our next problem. Look at the function, and we are going to take the limit as x approaches 0. Again, we will do it graphically, but I also want to talk about a little bit analytically here. Okay. What do you see? 5 to the power 1 over x, right? What you need to understand is the 1 over x itself goes to plus infinity as x approaches 0 from the right. These are again some very important ideas in evaluation of limits. Okay. When x goes to 0 with positive values, 1 over x will be large positive. Similarly, 1 over x goes to negative infinity as x approaches 0 from the left side with negative values, right? So that means in this function here, if you look at the left hand limit and right hand limit separately, at one point it will be 5 to the power infinity, 1 over x will go to plus infinity, right? 5 to the power infinity, that will be infinity. So the overall it will be 1 over infinity, which is getting close to 0. So I can see that if when I approach from the right side, this function will go to 0. I'll explain once again. As you approach from the right, 1 over x goes to infinity. So 5 to the infinity will be infinity. So 1 over infinity becomes 0, right? You can see that it goes to 0. Whereas if you approach from the left, okay, when x approaches 0 from the left, you will have 5 to the negative infinity. Check this out. Okay. And it is 5 to the negative infinity. And when you take a negative infinite power of a number, the result is 0. Okay. That is like 1 over 5 to the infinity. So that result is 0. So what do you get? 1 over 1 plus 0 for the whole function. Okay. The limit of the whole function will be 1 over 1 plus 0, which will be 1. Right. So from the left side, it will approach to 1. On the right side, it approaches 0. So I can see two different limits for that function as x approaches 0. That is my very, what you call informal but informal analytic approach here. Let us see the graph. Here is the function I have plotted. Let me disable the other one. And you can see what I said. From the left and from the right, the limits are different. Approaches 0 from the right, approaches 1 from the left. Okay. Next. So the answer is, by the way, the answer option here will be does not exist because it has, the two one-sided limits are both exist, but they are different. Next. Here is a function which is a quotient function, not a rational function. The denominator is not a polynomial, okay? So we have to call it a quotient function. And what would be the values when x approaches 0? Interestingly, The function is not defined at 0, right? If you plug in 0, you are going to get 0 divided by 0, which is an indeterminate form, So f of 0 is undefined. So you are trying to get a hint now what happens when x gets closer to 0, right? We will see the graph again later, but let's do some analytic work, and there are some important concepts therein. The numerator, you would want to factor it. See, whenever you are trying to simplify, you see if you can factor expressions and cancel out some factors. Try that always. Okay. In the denominator, you see x cube plus x square. Now that is like there is x square in both of them. Okay. So you could isolate or factor that x square out, and what remains will be 1x with x out of x cube and 1 out of x square. Think of that step. Okay. You can factor out x square, and what remains is x plus 1. There is under root for that, and then you can split that into two things, right? Under root x square, under root x plus 1. Now you might be tempted to write this as x times x plus 1 over 3. Under root x square is x, right? Times root x plus 1, and then cancel out x, which is partially true. Okay. The complete story is you have to think that this is one of the cases. So what happens is there will be two cases, and tell me why. The reason is under root of 4, okay, not as 4, when it is expressed as like 2 square, um, is 2, okay. The under root by default is always positive, but the point is the same here. It is a variable x, okay. I could say that if it is a number, if it is a constant number, but if it is a variable and the same x is appearing in the numerator also, so we do not know whether we should, whether x is positive or negative, right? For example, I cannot say under root of x square is x. Why? Because x could be negative. So what if x itself was negative? So what I meant to say is under root of negative 2 squared is also 2. It's not negative 2. Okay. Because first you have to do the squaring inside, that becomes 4. And under root of 4 by definition is 2, not negative 2. For negative 2, you have to put a minus sign in front of the root, not inside. Okay. So, but when it is a variable x, how do you know whether it should be x or negative x? Right? So you have to consider two cases. If x is greater than 0, equal or greater than 0, then under root of x is x. But if x is less than 0, then the under root of x in the denominator, under root of x will be negative x. That's a very important concept, as I said there. Okay, what I said just now. Under root x square. So to summarize it, as a piecewise function, I will write here. Not I will write here, not complete. That statement is not complete. Okay, what you should say, a complete statement is under root x square is x if x is equal or greater than 0, negative x if x is less than 0. This is like the absolute value function definition. Actually, the best way to define under root x square is it's the absolute value of x. That is a precise way of defining. Okay, under root of x squared is absolute value of x, because the result has to be positive by definition of the root set. Okay, so it could be x or negative x, and now depending on that you will have two different answers, right? what will be the two different answers? Let us simplify one more step and then we will write. When you cancel the x here now and root x plus 1, you will be left with root x plus 1 over 3, and here two cases, right? Or root x plus 1 negative of root x plus 1 over 3, right? You get these two different expressions, and as x approaches 0, that will be either 1 over 3 or negative 1 over 3. Okay, that's my analysis here. And because the two-sided limits are 1 over 3 and negative 1 over 3, your limit does not exist. So answer option will be B. Let us see. My claim is the left side and the right side limits are 1 over 3 and negative 1 over 3. Let us see that in our graph. Take the function here, the third one. Okay, I'll disable this, enable the third option, graph, and what do you see here? Okay, and this is what I had used the scale earlier for. Let me change the step size on y-axis. On y-axis, I'm choosing the step size to be 1 over 3. Okay, and then you can see that when you choose 1 over 3, I hope you can read it, 0.33333, right? That is the limit on the right side. And on the left side, the limit is where that line is meeting the y-axis. Okay, you see a vertical segment there. I was trying to understand it. Okay, I spent some time zooming in. I guess that is an anomaly because this is a numerical approach, right? So the calculator is going crazy, okay, because the values are so close to 0. The If you zoom in here, you see where it meets. Yeah, that's 0.333, negative 0.333. Okay, so it sometimes disappears, in some resolutions, but sometimes it comes back. It's a little funny. Okay. Yeah, negative 0.333. So negative 1/3 or positive 1/3. Okay, good. Hope you are also learning, how you can use actually graphs to estimate the limits. Okay. Next few questions will be about understanding these one-sided limits and the situations. Look at this function, and you have to evaluate limit as x approaches 3 if it exists. Okay. So these limits, always come with that condition. Okay. The limit may not exist, so you say if it exists. And let us see. We'll look at the graph. Okay. The graph of the line x minus 1 and the graph of the line minus 2x plus 8. And you can see that all of them have this different functions here. That itself would be a clue to your answer. Which graph has x minus 1 and minus 2x plus 8 on these intervals, right? So from that you will know which option to choose. And then we can see whether it matches in terms of the limits or not. Okay. X minus 1, slope is 1, y-intercept is negative 1. So none of these graphs make sense. Okay, the y-intercept is not negative 1 here. Where is the y-intercept negative 1? Here. Because that is again for x less than 3, So when x is 0, that is on the y-axis, you should see that y-intercept. So option D here matches that. The first rule here for x less than 3. And for x greater than 3, the formula is negative 2x plus 8. Now, where do you see negative 2x plus 8? Here. Negative 2x plus 8. Think of that. If you set it equal to 0 and solve, you will get x equals 4. So that is your x-intercept. Or if you think about it, its slope is negative 2. right? Negative 2x. So slope is negative 2, and that, sorry, positive 2, my bad, not negative 2, positive 2, or negative 2, double bad, okay? Equation is negative 2x plus 8. The slope is negative 2. So when you go 1 unit left, you go up 2 units. From there also you can figure out the slope is negative 2, left and up, right? So this is the graph. And what you see in this graph, as x approaches c, they meet here. So the limit is 2. The limit of the function is 2 as x approaches 3. Okay, so my answer is 3, 2, sorry, limit is 2. But can we also see it analytically? It's simple. Plug in here. 3 minus 1, 2. Over here, negative 6 plus 8. Right? For both of them, when you plug in x equals 3, you get the same result 2. Hence, the two one-sided limit exists and they are equal, hence the limit exists. Okay, so the limit of the function is that 2. Okay. All right. I zoom in and zoom out to focus on different things. Okay, I have to be conscious that it's not too distracting. I'll do it gradually. Okay. Here is one more question of similar type, but right now I have to zoom in to show you where to focus on. Okay, we are looking at a left-hand limit only, not the two-sided limit, one-sided limit. Okay, approaching negative 2 from the left, and that is significant because the rule is changing exactly at negative 2, right? So you need to worry what rule to consider when you are approaching from the left. And if you think about it for 2 seconds, you realize you have to consider the first rule. That is the rule which is applicable on the left side of negative 2, right? X equal or less than negative 2. So when you plug in negative 2 here, we are going to get negative 2 plus 4 equals 2. Your answer is 2. As simple as that. Okay. And can we see that in a graph? From the left, x equal or less than negative 2, the equation is x plus 4. For the function x plus 4, the x-intercept is negative 4. You can check that. If you set it equal to 0, f of x equal to 0, you get x plus 4 equal to 0. So x is equal to negative 4. So the x-intercept is negative 4. It makes sense. And the slope is 1. So that this line is perfect. Okay. And you can see that, the value of the function is also 2 matching. But we have to make sure, okay, that's not enough actually. How bad? It could be this as well, right? They have the same thing on the left side. All of them. No, okay. We have to see the part written below also. Okay. With that graph, this conclusion. With that graph, this conclusion. No, which is the correct option? Both if these graphs are good, those are the graphs actually of the right hand side function is negative 2x plus 1, and you can see that line is negative 2x plus 1. Okay, slope is negative 2 and y-intercept is 1, right? So the graphs are good, but the conclusion that limit does not exist is not true, or the limit is equal to 5 is also not true. Limit is equal to 2. So let us check. Here you have option D. It says the limit is 2. Okay, and it's the same graph. Option C is not correct because it shows open on both sides, which is not the case. It should be closed here or equal or less than 2, negative 2. Okay, so D. is the correct answer. D is the correct answer. Okay, moving on. Use the graph to guess the limit if it exists. Okay, just guess from the graph. Like no more analysis needed. This is x plus 1. So you should be looking at the point when x is equal to -1. That is the only time you have to worry, right? The denominator becomes 0. But then if you look at the graph, you see there is a hole at 2. So your answer is simple. Limit x approaches -1 of that function is 2. Function is not defined, but its limit is 2. It is approaching the same value from both sides as you see in the graph. Okay. And the fact that there is a hole means the factor in the denominator must get cancelled, right? Recall that from pre-calculus or college algebra, whichever course you have taken. And how would I know that? You can factor the numerator. X plus 1 times x plus 3. Check that. Okay. Divided by x plus 1. And when x is not equal to -1. Okay. When x is not equal to -1, you can cancel the x plus 1 as a factor. You are left with x plus 3. Now you plug in -1, you get -1 plus 3, 2. So the limit is 2, as you can see in the graph. Okay. Here is another question. If the limit of that function approaching from the right hand limit is 5.6 and the limit exists, then what is its value? Okay. Concept question. Please think of your answer and tell me that you thought it's 5.6. Same. Why? Because if the limit exists, then that limit should be the same as the left hand limit and the same as the right hand limit. That is when the limit exists, in fact. Okay, so when it exists, all of them will be equal. That is the idea. If they were not equal, it would not, you would not say the limit exists. All right. Here is again a repetition, almost repetition of one of the previous questions, but it is 0 plus. Be careful here. So it is what we are only talking about one-sided limit. Okay, and because we're talking about one-sided limit, this is easy. Okay, 1 over x will go to plus infinity in this case, and because of that you will have that function approach to 1 over 1 plus infinity. 8 to the power infinity will be infinity, which is 0. So your answer is A. Okay. This is another practice problem for you. I am skipping it. You can do it. Just plug in the value. Here is a question on vertical asymptotes. Okay. And the idea is a rational function or a quotient function will have a vertical asymptote if the denominator goes to 0, but the numerator does not. Right? So what you do, you set the denominator to 0. 9x minus 4x square equal to 0 for vertical asymptotes. Okay, set that denominator equal to 0 and you factor out x, you get 9x minus 4, no, 9 minus 4x equal to 0. And when you solve, you get x equal to 0 and 4 over 9. Okay. and none of these is the correct answer. Okay, so answer option is B. See, the fourth option, option D, had 0 in there, but it also had 1 over 4. That's not correct. Okay, it's 0 and 4 over 9. It has to be completely 2, If it only gave x equal to 0, I would have ticked it. You can miss something, but you cannot write a wrong value. You don't have an asymptote at x equal to 1 over 4. Okay. And after that, there are this you do it numerically by using a calculator. And I have included questions with answer options almost everywhere. Okay, that is for you to practice. Do download the document and try to do all of this homework as much as possible. Here is again another numerical work that you can do. Now it asks you to do these calculations, okay, and then predict the limit based on that, and you can do it, okay, numerically. Um, Again, do the function graphing and zoom where it intersects the y-axis and estimate the value of limit as x equals to 0 of f of x. Okay, so estimate the point where the graph crosses the y-axis. Means what? That's the y-intercept, right? And if that is the y-intercept, that should be the same as limit of the function f of x as x approaches 0, right? That's where we have y-intercept, and you can try that. These are step functions. You can try, do some work like I did before. This is a huge document with a lot of questions. Okay, I would recommend that you try to do each one of them. I'm only trying to cover variations if possible. Okay, when the questions are repeated, I will skip that. Um, Here is one concept I can talk about. You have to find the limit here, and you're approaching from the right. Okay, u approaches to plus. So if you approach from the right, that u minus 2 will be positive 0, 0 plus, greater than 0, but small. And the numerator would anyway be u squared will be 4. See, u is approaching 2, not 0. Okay. So the numerator will be approaching 7 times 4, which is 28. Whereas the denominator will be approaching 0 from the right. As a result, your 28 divided by 0 from the right, your answer is plus infinity. Okay, that is the idea. You can see that you can verify my answer. And what about this? Negative, no, not negative. X approaches pi over 2 from the left. Okay, X approaches pi over 2 from the left. And no, I guess there's a typo here. X approaches pi over 2, then answer would have been plus infinity. Okay, so I don't know, I placed the minus and I guess in the wrong position. The answer here should be B, not A. Okay, because if we approach x from pi over 2 from the left, the graph of cos x is like that. Pi over 2 is here. If you approach from the left, the values of cos x will be positive, and 2 divided by something positive will be plus infinity, right? So the correct answer should be B. Or I might have made a typo when I was not thinking of placing the minus sign in front of 3, but I ended up placing it with the exponent here. Okay, so with the question as it is typed here, the answer should be plus infinity, and I was justifying that here. As you approach from the left, cos 90 degree, from the left will be positive 0, not negative 0. Okay, right? And one more question here. Find the function whose graph is given and then find the limit. Okay, finding the function whose graph is given, there are going to be 1, 2, and 3 components. Okay, for that graph. So first of all, you are going to define a piecewise function. And what will the exact equations be? I will not get into too much details here, okay, in this video. The middle one, it looks like tan graph to me. And on the right side, it could be either a hyperbola or some logarithmic function which is decreasing very fast, okay. So lots of possibilities there in terms of equations. I will not write that. Let us look at the limit. X approaches -1 from the left. Look at the graph. And if you look at the graph, here is your -1. Okay. And as you approach -1 from the left, the function is rising, right? So answer to that question will be plus infinity. All right. What else? X approaches -4 of f of x. Let us look at where -4 is. -9 is here. So 8, 7, 6, 5, 4. Okay. And there is a vertical asymptote there. So because it has a vertical asymptote, it has a infinite limit, but it is approaching the same side with values less than 4 and more. Okay, less than -4 and more. So it is safe to say this limit is negative infinity. Okay. Like that, we discussed many problems actually on this topic. The remaining problems that we did not cover in the video, please complete them on your own. Okay. I would have left enough, possibility. And thank you for watching. See you in the next video.